Welcome friends. In last few lectures we have discussed the transmission line parameters, that is how to calculate inductance and capacitance. Now from now few lectures we will discuss the performance of the transmission line. That means the types of the transmission line, how voltage and current equations related to each other, and power flow through the transmission line. So it has already been discussed that transmission line, what is transmission line? Transmission line that carries power from sending end to the receiving end. And the transmission line is characterized by the four parameters. Two of them are series and two of them are shunt. So in the series parameter we have R and we have L. So altogether they will form series impedance, that is R equal to Jx. And in shunt we have G and we have C. Now G is neglected because of its small value. So we have C and we have shunt admittance. So primarily we have series impedance and shunt admittance. Now these parameters of the transmission line is broadly classified into two groups. Parameters of the transmission line can be broadly classified into two groups. Group number one is called lumped parameter model. Lumped parameter model is distributed parameter model. Distributed parameter model. What is the difference? It is observed that when the transmission length of the line, if the length of the line is relatively slow, when the length of the transmission line in the typical in the order of 100 kilometer, then to analyze the transmission line, if all the parameters are assumed to be lumped at one point, that feature is called lumped parameter models. That feature is called lumped parameter model. That means entire impedance of the transmission line and entire admittance of the transmission line is lumped at this point. So this is called lumped parameter model. So this is called lumped parameter model. This is Vs, this is Vr. On the other hand, when the length of the transmission line is above 250 kilometer, then the transmission line parameters are assumed to be distributed. Transmission line parameters are assumed to be distributed along the entire length of the line. Transmission line parameters are distributed along the entire length of the line. So this is called distributed parameter model. This is Vr. This is Vs. It is called distributed parameter model. This distributed parameter model will give you more accurate result. However, these two models, that is lumped parameter model, and distributed parameter model, lumped parameter model and distributed parameter model will produce almost same result. However, this distributed parameter model will produce more accurate result. Now, having said that, the transmission line can be categorized into three groups. The first group is called short transmission line. Second group is called medium transmission line. And third group is called long transmission line. What is the basis of this classification? Now, in short transmission line, the length of the transmission line, length of the line typically is less than 100 km. In medium transmission line, length of the transmission line in between 100 to 250 km. And in long transmission line, its length is greater than 250 km. Moreover, as the length of the transmission line as the length of the short transmission line is less than 100 km, its shunt admittance does not contribute any significant proportion the performance of the transmission line. Hence, in short transmission line model, this shunt Y is neglected. So I repeat, in short transmission line, as the length is very less than 100 km, this shunt Y, if the overall model of the short transmission line is analyzed, then it is found that this shunt admittance does not contribute any significant part to the overall performance of the transmission line. Hence, shunt Y is neglected in case of short transmission line. So, a short transmission line is represented nothing but a series resistance with an inductance. Simple. This is Vs and this is Vr, which is receiving end and sending end. This is R, this is X, and current should be flowing I. So this is the equivalent circuit of short transmission line. Now coming to the medium transmission line. Shunt Y, that means shunt admittance, contributes significantly. So shunt Y is considered here. It is not neglected. Shunt Y is not neglected. However, since the length in between relatively in the medium range, so 100 to 250 km, then this model or the equivalent circuit of the medium transmission line can be considered as a lumped parameter. That means a series impedance and a shunt admittance like this. A shunt admittance like this. This is called lumped parameter model. So this is Z and this is shunt admittance Y by 2. So this is Vs and this is Vr, and the current flowing from Vs is Is and current flowing through Vr is Ir. This is called equivalent pi section model. This is called equivalent pi section model. Equivalent pi section. Another way, another lumped parameter can be considered in case of a medium transmission line, which is like this. The impedance part, series impedance, has been split into two parts, and shunt admittance is considered in this way. This is Z by 2, this is Z by 2, this is Y. So this is the lumped parameter. We have Vs here, we have Is here, we have Vr at receiving end, and we have Ir at receiving end. This is called equivalent P section model. So a medium transmission line either can be represented as a equivalent pi section model. Equivalent, it is either represented either in equivalent pi section model, or it can be represented as a equivalent T section model. However, in practical analysis part, always this pi section model has been considered. Always this pi section model has been considered. So in medium transmission line, what is considered here? It's a lumped parameter model. It's considered lumped parameter model. Lumped parameter. Now coming to the long transmission line. It is, long, in case of long transmission line, as the length is very large, to get the accurate result, always distributed parameter model is considered. Distributed parameter model has been considered. What is distributed parameter model? That means Z, I'm going down, in case of long transmission line, distributed parameter model is considered What is distributed parameter model? The impedance and the admittance is distributed along the entire length of the transmission line. This is called distributed parameter. Yes, we have IS at sending end, and we also have VR and IR at receiving end. These small portions having length of dx, which is having impedance z dx and shunt admittance as y dx. Now, most interestingly, this lumped parameter models, and distributed parameter model, as far as the result is concerned, this distributed parameter model is more accurate. It's more accurate. However, their result, or if you analyze using lumped parameter model and using distributed parameter models in two different ways, their result should not vary too much. Means the result obtained from lumped parameter is not that bad. So sometimes long transmission lines are analyzed, long transmission line are analyzed using equivalent pi section model. Equivalent pi section model. Because of this fact, some group of people considered medium length of the line as long transmission line as well. Medium length of the line as long transmission line as well. So there are two opinions actually. There are two opinions altogether. First group of people say there are three types of transmission line: short, medium, and long. This, what is the difference? It is the shunt Y is neglected. In medium transmission line, lumped parameter model is considered. In long transmission line, distributed parameter model is considered. As the lumped parameter model and distributed parameter models will produce almost same result, although distributed parameter models is more accurate. That is the reason long transmission line, sometimes this long transmission lines can be utilized. Long transmission line can be utilized using, or can be analyzed using, equivalent pi section model. Equivalent pi section model. That is why some group of people categorize transmission line as short and long transmission line. That means anything less than 100 km is short, and anything greater than 100 km it's long. However, the name does not matter much. You must remember one thing, that anything length of the transmission line, anything less than it is short, and for that transmission line shunt Y is always neglected because it will not affect significantly to the overall result. And if the length goes high, 100 km, so if it is stays around 100, 120 up to 200 to 20, so medium, the lumped parameter model can be considered, and it will give you satisfactory result. However, if the length goes more high, specifically greater than 250 km, it is better to use distributed parameter model for better accuracy. However, In some cases, in some journal papers, people have worked or people have used lumped parameter model for long transmission line. That is why some group of people categorize transmission line as short and long. So medium lines can also be considered as a long line. With this, now let us come the voltage and current equation of a transmission line. Voltage and current equation of a transmission line. How voltage and current equation are related? Voltage and current equation of transmission line. Suppose this is a transmission line model, either it is a lumped parameter model or distributed parameter model. It has a sending end, it has a receiving end. At sending end we have Vs as sending end voltage and sending end current as Is. Also we have Vr at receiving end and IR as receiving end current. So these four parameters are interlinked with in this fashion. Vs is equal to AVR plus BIR and Is is equal to CVR plus DIR. This ABCD parameters are called T parameters or transmission line parameters. How can they be defined? You see, if you put IR is equal to 0, then A can be defined as Vs by Vr. It is the ratio of two voltages. So it should be unitless. Moreover, if you consider IR is equal to 0, then C would be is equal to Is by Vr. So as it is the ratio of current by voltage, so it have a unit of mho. On the contrary, if you consider Vr is equal to 0, that means opening the receiving end. So you know, when Vr is equal to 0, then B can be written as Vs by IR. Now as it is a ratio of voltage by current, it bears a unit of ohm. And lastly we have D. D is the ratio of Is by IR. Lastly we have D. It is equal to Is by IR. It will be unitless. So essentially transmission line parameters ABCD can be defined by these four equations. Lastly, to study different performances of the transmission line, we use more two terms, that is, what is voltage regulation? What is voltage regulation? It is defined by no load voltage minus full load voltage minus full load voltage by full load voltage. So in notation it is called VNL minus VFL by VFL. into 100%. Lastly, we have efficiency, which is equal to output power, that means power at receiving end, divided by input power, that is power at sending end, into 100%. It can be written as output power divided by input power, can be written as output power plus losses. With this, I am ending this part. From the next lecture, we will study short transmission line. Thank you.